Good morning children, I hope class 8 children are watching this video and I hope you must be keeping well. As just now we have completed operations on algebraic expressions, addition, subtraction, multiplication, division we had seen, and even we had completed exercises related to it. I hope each one of you must have watched properly and must have completed each and every question. Today we are going to see a new chapter, that is volume and surface area of solids. So this, before starting, I would like to tell you this chapter is very important because the same thing you have to learn in class 9th and 10th. So watch properly, try to learn properly and be with your book and copy so that together you can learn properly, and later you need to practice in proper way. So today in this class we are going to see a cuboid and cube, formula for volume and surface area of cuboid and cube, and some solved examples we are going to see. So for cuboid and cube we will see in proper way what are cube and what are cuboid. So in very basic way I would like to tell you, both are solid figures. Already you have learned before in previous classes. Both are solid figures having 6 faces and 12 edges. So this I would like to explain with the help of your book. Let's see. Here you see you have cuboid and cube. Before that, here you see solid bodies occur in various shapes. In our previous class we have learned about cuboids, cubes, cylinders, cones and spheres. Already you have done. But then also for review, just to see what are cuboid and cube. A solid bounded by 6 rectangular plane faces is called a cuboid. So just you see the figure what has been given here. A, B, C, D. This is your first face or first surface. Second surface you have E, F, G, H. This is your second surface. Then you have here you see B, F, G, C. This is the third one. Then you have A, E, H, D. This is one. This is your fourth one. And A, E, F, B is your fifth one. And D, H, G, C is your sixth one. 6 faces are there. They are called faces or rectangular plane faces. So 6 faces are there. And these are called edges. Suppose A, B, D, C, E, F, AE, BF, HG, GC. So these all are called edges. So just you see solid figure, and in solid figure how it has been defined? A solid bounded by 6 rectangular plane faces is called a cuboid. So 6 faces are there and 12 edges are there. So this is called cube or cuboid. Difference is what in between cube and cuboid? Here you see, suppose this is cuboid and this is cube. In cuboid you have, suppose this is length, this is breadth and this is height. 3 things are there, 3 dimensions are there, length, breadth and height. Here also the same thing you have, length, breadth and height. Both are the same figure. Difference is what? Here you have length, breadth and height may be of different sizes, but in cube all will be equal. In cube length, breadth and height will be equal, but here in cuboid they may be equal or may not be. So all cubes can be said cuboid, but all cuboid cannot be said cube. That you need to remember. Here you see. So if you are sitting in a room, just you assume your room is a cuboid. This is your floor area, E, F, G, H. This is your floor area. A, B, C, D is your ceiling. Just you watch your room. A, B, C, D. This is your ceiling. So this is your floor area. This is your ceiling, and 4 walls you have. So all are in rectangular shape. Just you see E, F, G, H in the shape of rectangular. Just you see your floor, your ceiling. You see that is also in rectangular shape, and 4 walls what you have. Just you look around and see all are in rectangular shape. So all together this will be called cuboid. And in cube, simply you remember, cube is also a type of cuboid having all sides equal or all dimensions equal. 3 dimensions you have, length, breadth and height, all are equal. So some examples have been given of cuboid: a matchbox, chalk box, tea packet, a brick, a tile, a book, etc. are all examples of a cuboid. Here you can see this is a book. It is having 6 faces, rectangular faces. This is in the shape of rectangle. 6 rectangular face it has. First, second, third, fourth, fifth and sixth. This is 6th one. And edges you see, these are all are called edges. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can see and you can count and you can understand. And so here, suppose in this way it has been kept. So suppose if we are assuming this is length, and this is breadth, or this is length and this is breadth and this is height. So length, breadth and height, 3 things are there in cuboid and cube both. But in cuboid, length, breadth and height may be different, but in cube all are same, all are equal. So here it has been written, a cuboid has 6 rectangular faces, 12 edges and 8 vertices also. These will be called vertices, this corner where 3 lines are meeting at a point, these will be called vertex. So 8 vertices we have, 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices we have in cube and cuboid. Any face of a cuboid may be called its base. So any face of a cuboid may be said its base. Suppose if you are keeping your book in this way, so in this way, this will be called your base. If you are keeping your book in this way, then this face will be called its base. The 4 faces which meet the base are called the lateral faces of the cuboid. The 4 faces which meet the base. Here suppose E, F, G, H is your base. Then 4 faces. This, suppose if you are keeping this one in this way, then this is your base. 4 faces. This 1, 2, 3 and 4. Or if you are assuming your room, just you see, your base is your floor and 4 walls what you are saying. So those 4 walls will be called lateral surface. So these these 4 walls or 4 sides will be called lateral surface. 6 faces are A, B, C, D, E, F, G, H that has been given. Just now I made you understood what it is. Then you have cube. A cuboid whose length, breadth and height are all equal is called cube. Means this is also a cuboid but having all length, breadth and height equal. Examples of this is ice cubes, sugar cubes, dice, ludo and all we play with this dice are all examples of a cube. Each edge of a cube is called its side. And edges, these edges, AB or EF or EH or FB, these all edges will be called its side. Then we have volume of a solid, the space occupied by a solid body, it's called its volume, that we know. The space occupied by a solid body is called its volume. So standard unit of volume is what? The standard unit of volume is cubic centimeter, written as CU/cm. or centimeter cube. The volume of the cube of side 1 centimeter is 1 centimeter cube. So volume of a cube is what? L into B into H. So suppose one side is 1 centimeter. Then volume of cube, because that all will be equal, 1 centimeter into 1 centimeter into 1 centimeter, and that will be 1 centimeter cube. The other units of volume are millimeter cube, decimeter cube, meter cube, liter, etc. Then we have convergence of units. Here already you have learned before, so I hope you will know this. 1 centimeter is equal to 10 millimeter. 1 decimeter is equal to 10 centimeter. 1 meter is equal to 10 decimeter, and 1 meter is equal to 100 centimeter. So these things you need to understand. 1 centimeter is equal to what? 10 millimeter into 10 millimeter into 10 millimeter, that is mm cube, or 1000 mm cube. 1000 millimeter cube is called 1 ml. So that you need to remember. And these conversions have been given that you go through properly and you by heart, you remember this. So in very simple way I am going to tell you for length what unit we keep, or length measurement how we see. Suppose 1 millimeter is equal to 10 millimeter is equal to 1 centimeter. 10 centimeter is equal to 1 decimeter. 10 decimeter is equal to 1 meter. And therefore, just you see, 1 meter is equal to 10 into 10 means 100 centimeter is equal to 1 meter. And 1000 centimeter 1000 millimeter is equal to 1 meter. That you need to remember. And then we have 10 meter is equal to 1 decameter. 10 decameter is equal to 1 hectometer. And 10 hectometer is equal to 1 kilometer. And one more thing you need to remember, 1000 meter is equal to 1 kilometer. So these things already you have learned before, you must remember this. Here you see formulae for volume and surface area of cuboid and cube. So volume of cube is what? Volume of cube is cuboid is length into breadth into height. It means L into B into H cubic units. If centimeter will be there, cubic centimeter, meter will be there, cubic meter, and so on. Diagonal of a cuboid is equal to, you need to remember, root under L square plus B square plus H square. So just you see, suppose this is your cuboid. This is your cuboid. So diagonal will be this one. This one. This is your diagonal. So diagonal will be root under L square. This is L. This is B, and this is H. L square plus B square plus H square. This you need to remember. Then total surface area of a cuboid, and that is equal to 2 into LB plus BH plus LH square unit. How it comes? Just you see. Total surface area of a cuboid. This you see. Suppose if you are having, this is your cuboid. In this shape. This is your L. This is your L, this is your B, and this is your H. Now, you need to find out total surface area. So how many surfaces are there? 6 faces are there. 6 faces you have. Just you see, this is your base. This area is your base. So if you want to find out the area of this face only, it means suppose if you are in a room, this face will be your floor. So if you want to find out area of this floor will be L into B, because this is a rectangular shape. So first area you will be having L into B. This you have got L into B. Same area you will be having of your ceiling. If you are saying your room, this is your ceiling. So area of this base or area of floor will be equal to area of this ceiling. So both will be equal. So you can write 2LB and plus you see 4 walls you have. Suppose this wall you are taking. So here you have one side B, the other side H. So this can be written as B into H, BH. So again here you have 2 faces similar. So this area and this area, suppose just opposite 2 walls, one pair of wall you take. So that will be B into H. So 2B into H and plus, just you see, again remaining one pair of wall, that will be L into H. This face you see. This face and just opposite to it. So this will be L into H. So 2LH it will be. 2 can be taken out common. So what will be left? LB plus BH plus LH. And this is the surface area of a cuboid. So this we have got total surface area of a cuboid. Lateral surface area of a cuboid will be what? Here you see, here itself. Lateral surface, this is total surface area. Total surface area. If lateral surface area you want to find out, lateral surface area, just now it was told, the area of 4 walls. Simply you need to find out area of 4 walls. Your floor and ceiling you don't have to count. So just this portion you leave, 2LC. If this portion you are leaving, then what will be left? 2BH into plus 2LH. Means these 2 sides, one pair of walls, area of one pair of walls, and area of the other pair of walls. So that will be 2BH plus 2LH. Now this can be written as 2BH plus 2LH. Now 2H can be taken out common. So it will be left with B plus L or L plus B. So 2H into L plus B will be lateral surface area of a cuboid. Here you see, lateral surface area of a cuboid is equal to 2HL plus B or 2L plus B into H. Whatever, in whichever way you write, you will get this. Now you have cube. Since cube is having all sides equal, and that's why here you see, and we have got area of cuboid, volume of cuboid we had got L into B into H. But here you have all sides equal. Then in this case A into A, it means A cube you will get. Just you see, volume of the cube is equal to A cube. Diagonal of the cube, what we had got? Diagonal of the cuboid we had L square plus B square plus H square under root. So in place of this, we will be having what? We will be having A square plus A square plus A square. It means 3A square. We will be having root under 3A square. It means A root 3 or root 3A. A root 3 or root 3a. Now total surface area of a cube. Total surface area what we had got? 2 LB plus BH plus LH. This we had got of cuboid. Now here all are equal. So this can be written as A into A square plus A square plus A square means 3A square into 2 means 6A square. So total surface area of a cube is 6A square. Now lateral surface area of a cube, lateral surface area of a cuboid was what? 2L plus B into H. So just you see, if all will be equal, so this will be 2A plus A into A. It means A plus A is 2A, 2A into 2 is equal to 4A into A means 4A square. Just you see, lateral surface area of a cube is 4A square. So in this way, the basic things what we have understood. Now we will see some solved examples. First example you see, find the volume, the total surface area and the lateral surface area of a cuboid which is 8 meter long, 6 meter broad and 3.5 meter high. So it is better whenever question you will see, just you draw a figure so that you will understand in better way and clear picture you will be having how it could be solved. Here you see, suppose you have a cuboid, you need to find out volume and total surface area and lateral surface area of a cuboid which is 8 meter long. A is equal to 8 meter. Then you have 6 meter broad. This is B is equal to 6 meter. Then you have 3.5 meter high. 3.5 meter. And unit you need to see all should be equal. If it is not equal, suppose this is in meter, this is in centimeter, this is in decimeter, or in some other unit, you need to make that equal first, then you should proceed. So here you see volume of the cuboid we know L into B into H. So just you see L, B, H has been given. Formula you need to remember. So 8 into 6 into 3.5. So just you multiply, you will get the answer 168 meter cube. And this unit, how to write unit also you should know, because this is volume, 3 times you are multiplying meter. So this will be meter cube. In the same way, total surface area, when area will be there, this will be square unit. So if this will be meter, this will be meter square. So volume, total surface area of the cuboid, that formula you know, 2 into LB plus BH plus LH. So just you put the value and simplify, you will get 194 meters square. Then you have lateral surface area, that formula also you know. Lateral surface area, always you remember area of 4 walls. So just you see 2 into L plus B into H, just you put the value, you will get this. So this way we have done example 1, example 2 you see. How many bricks will be required for a wall which is 8 meter long, 6 meter high and 22 meter 5 centimeter thick if each brick measures 25 centimeter into 11.25 centimeter into 6 centimeter. So length of the, just you see, here you have been given 8 meter, 6 meter and 22.5 centimeter. Now here what you need to know, that first of all this should be made equal. Here centimeters are there, so that is required to be made equal. So length of the wall is 8 into 100, it should be made, so that it will be 800 centimeter. Breadth of the wall 22.5 centimeter. Height of the wall 6 into 100, that will be 600 centimeter. Now volume of the wall will be 800 into 22.5 into 600, and volume of one brick is equal to what? 25 into 11.25 into 6 centimeter. So centimeter cube. Now number of bricks will be what? Volume of the wall divided by volume of one brick. So volume of the wall, you know, the same formula will be applied. 2 into LB plus BH plus HL divided by 2 into LB plus BH plus LH. But value we have different of wall and brick that you need to put, and then you need to find out. Then we have question number 3. Find the length of the longest pole that can be put in a room of dimensions 10 meter by 10 meter by 5 meter. So again, if here you need to find out diagonal. Longest pole it is saying, it means you need to find out diagonal of that room. So diagonal will be the length of the longest pole, what you can put in that room. So that formula you know, under root L square plus B square plus H square, this value is required to be put, and simplify, you will get the answer. Then we have question number 4. A field is 80 meter long and 50 meter broad, you can see. In one corner of the field, a pit which is 10 meter long, 7.5 meter broad and 8 meter deep has been dug out. The earth taken out of it is evenly spread over the, means earth taken out of it means the soil whatever has been taken out after digging. So that is required to be spreaded evenly over the remaining part of the field. Find the rise in the level of the field. Suppose here pit has been made and soil what came out that has been spreaded on it. And then you need to find out height of this area, of this field. How it will be solved, just to see. Area of the field now is 80 into 50. 80 into 50. So that is 4000 meters square. Area of the pit, that is 10 into 7.5, that is 75 meters square. Area over which the earth is spread out. So just you see, if soil is being taken out from here, that will be spreaded on this area, not in this pit. So that area is required to be subtracted, where soil is required to be spreaded. So that has been subtracted. In this area, soil is required to be spread in this area. So how we have found out? Area of the field minus area of pit. Now volume of the earth dug out means how much earth or how much soil has been taken out. So that is 10 into 7.5 and deep, this is 8 meter deep, which means this has been become as a cuboid. This pit what has been become as a cuboid, like in this way. So this is 7.5 and deep is how much? 8. Length, breadth and height. So volume of the earth or volume of pit is 600 meter cube. Now rise in level will be what? Volume of the earth dug out divided by area over which the earth is spread out. So just you see, you will get volume, or just in other way also it could be done. What volume you are taking out or what volume you get after taking out soil will be equal to the volume of this area. Volume of this area. The volume of this area would be L into B into H. So H would be volume of the earth dug out divided by area over which the earth is spread out. Or directly you can put this formula. Volume of the earth dug out and area over which the earth is spread out. So this will be 600 by 3925. It means 15.3 centimeter. Again I am making you understand. This volume what we have got, this volume means 7.5 into 10 into 8. The same soil has been spreaded over here. So how much area was there? In how much area that has been spreaded? In this area. Why? Because in this area again it will not be spreaded. This area has been subtracted out. So here you have this area. 3 3925, and volume will increase over here. So that will be length into breadth into height. So length into breadth already we have, area already we have, h we have to find out. So h into 3925 will be the volume of soil which is being spread over here. So therefore h will be equal to 7.5 into 10 into 8 divided by 3925. The same thing has been done over here. So if you are multiplying this, you will get 600. So 600 divided by 3925 has been done. Question number 5, you see. The volume of a rectangular tank is 182 meter cube. If its length and breadth be 8 meter and 6.5 meters respectively, find its depth. So easy it is. Volume has been given, length and breadth has been given, h you need to find out. So let h is equal to x or height is equal to x. So this will depth is equal to x. So 8 into 6.5 into x is equal to 182. So x will be 182 divided by 8 into 6.5, and then you will get 3.5. Then we have question number 6. The volume of a reservoir where water is reserved. The volume of a reservoir is 108 meter cube, like dam and all. Water is poured into it at the rate of 60 liters per minute. How many hours will it take to fill the reservoir? This type of questions are very important for the exam, so you need to understand properly. Suppose here it has been given volume of the reservoir is equal to 108 meter cube. It means how much liter? 108 into this you need to remember. This one you need to remember. Why 1000 is required to be multiplied? Because we know 1 meter cube is equal to 1000 liters. This you need to remember. 108 into 1000 liters. So rate of flow of water is what? 60 liters per minute. So we have this much liters are required to be filled. So 60 liters per minute it is. So how much time it will require? So volume of the reservoir in liters divided by rate of flow per minute. So that is 108 into 1000 by 60, and that is 30 hours we have got. So this was in minute, that's why that has been converted into hours. Find the volume of wood used to make a closed rectangular box of outer dimension 60 cm into 45 cm into 30 cm. The thickness of the wood being a 2.5 cm all around. Also find the capacity of the box. So here you see, suppose you are having in this shape you have box, wooden box. In this shape, but this thickness has been given. This is how much thickness has been given, you can see. So you need to find out how much wood will be required. So external length, this is external length, outer boundary. External length is 60 cm. External breadth is 45 cm. And external height is 32 cm. External volume will be what? 16 to 45 into 30, it means 86,400 centimeters cube. Now internal length, this length we need to find out from here to here. Because this thickness has been given, this is this much thick. So inner length will be, just you see, if this is 60, so from this side also thickness is required to be subtracted, and from this side also thickness is required to be subtracted. Thickness is 2.5, so two sides it is required to be subtracted. So 2 into 2.5. So 60 minus 2.5 into 2, you will be having length of inner length. So this is 60 minus 2.5 into 2, that is 55 centimeter. In the same way, internal breadth, 45 minus 2 into 2.5, that is 40 centimeter. Internal height will be 27 centimeter. Now internal volume is equal to 59,400 centimeter cube. So what is needed to be done? Capacity of the box will be the internal volume. Means capacity of the box means anything if you are keeping inside the box, so that capacity will be counted. So inside capacity will be the inside volume of the box. So here you see capacity of the box will be internal volume, that is 59,400 centimeter cube. Volume of the wood used to make the box will be what? Difference of both the volume. So if difference you are finding out, this volume you will get. This volume only you will get. This one. So just to subtract that, what you will get, that will be the thickness, that will be the volume of the wood has been used for making box. Then we have question number 8. An open rectangular cistern when measured from outside is 1.35 meter long, 1.08 meter broad and 90 centimeter deep. Again here you see meter and centimeter has been used, and is made of iron which is 2.5 centimeter thickness. Find the capacity of the cistern and the volume of the iron used. Same in the same way, just as previous question is what? In the same way this is required to be solved. Here you see in this shape you are having your cistern. So just you see some thickness is there. This has been made up of with iron, and some thickness is there of it in this way. This is the thickness. In this way. So just you see, external length of the cistern has been given 135, breadth has been given, and depth has been given. Now external volume you can find out, just to multiply you will get. Now internal length will be what? Again you need to subtract the thickness what has been given 2 times. 2 into thickness minus means length minus 2 into thickness, breadth minus 2 into thickness, and height or depth minus 2 into thickness. So internal depth of the cistern is 90 minus 2.5 because one side only is there, and that's why 2 sides it has not been taken. Just you see here somewhere it has been written. An open rectangular cistern. Here this is open. This one is open, and that's why 2 times it has not been subtracted. This side this is open. So internal volume of the cistern will be length, breadth and height has been multiplied, and you have got. So capacity of the cistern inside volume, its internal volume, whatever you have got, that will be your answer. And volume of iron used. This is your iron has been used, so that will be the difference of volume of external and internal. That will be your answer. Then you have question number 9. Find the volume, lateral surface area and the total surface area of a cube, each whose size measures 8 cm. So easy it is. 8 cm size is given. Only total surface area, only you need to know formula, and that you know. Volume of the cube is a cube, that you know. So just you put the value. Lateral surface area 4a square. Total surface area 6a square. In place of a you need to put 8 and you will get the answer. Question number 10 you see. Find the volume of a cube whose total surface area is 486 cm square. So total surface area as we know, that is 6a square. 6a square is equal to 486. So a will be what? 486 divided by 6, and a will be root under 486 divided by 6, and solve that you will get the answer. And so you can find out volume of the cube. Volume of the cube we know A cube that is. Then we have find the total surface area of the cube whose volume is 343 centimeters. So coagitating A cube has been given. A cube has been given 343. A you need to find out. Just to find out A. Then if you will get A, total surface area can be found out. Total surface area of the cube is what? 6A square. If A you will get, just put the value and you can find out. Then we have exercise. So suppose already this has been I have explained. So after that we have exercise. So in exercise also so 80 questions are there, just you try because many questions are there. All the questions will not be possible to be solved in the class, and that's why few questions just you try, just we go through. Up to here just you try to understand. Many times you watch video, yourself an example, whatever questions has been given you go through, try to understand, and then you start exercise 20A. If you will not be able to do, then few questions we will see in next class. Until then, thank you.